Purpose of this video is to go over question 29 on section 3.3 on Wiley. And this is an example of logarithmic differentiation when you have a constant to a function, so a constant to a power that's a function. And an approach on that is going to be logarithmic differentiation. So to set this up, I'm going to have the left-hand side, I'm going to call that y, and then I have sine or pi to the sine of 3x. And the process of this is to take natural log of both sides. And when I take the natural log of the left-hand side, I'm going to use properties of natural logs, and it's going to allow me to take this exponent and move it down as a coefficient. So I have ln of y equals sine of 3x times ln of pi. So that's the natural log part of it. And if you have a constant as your base, you'll always kind of end up with this ln of pi. And ln of pi is just a number. It doesn't simplify. You just leave it as ln of pi. And then the calculus part of it is to differentiate both sides with respect to x. So on the left-hand side, I have 1 over y times dy over dx. So it's the product, or the chain rule here. The derivative of the outside is 1 over whatever in the inside times the derivative of the inside, which is dy over dx, which is what I want to find. I want to find the derivative. So when I take the derivative of the right-hand side, to solve for dy dx, I'm going to take what I get over the derivative of the left-hand side, or to get the dy dx by itself on the left-hand side, I take the derivative of the right-hand side, but then I'm going to multiply it by y to solve for dy dx. That's a common mistake. You don't want to forget to multiply by y. So here, if I take the derivative of the right-hand side, ln of pi is a constant, so I can leave that as a constant. So I take the derivative of sine of 3x, which would be 3 cosine of 3x, times ln of pi, which is a constant. So cleaning it up a little bit, I can write dy over dx is 3 ln of pi, which is just a constant, just a number, times cosine of 3x, all multiplied by y. Now I don't want to leave it as y, because I want it as a function of x, and I know y is a function of x here. So I have dy over dx is 3 ln of pi times cosine of 3x times y, which is pi sine of 3x. So we get to enter that into Wiley. Going here, we have 3 ln of pi times cosine of 3x times pi to the sine of 3x. So just pulling up what we had before, making sure that's the same. 3 ln pi times cosine of 3x times pi sine of 3x, and I can check my work here by submitting my answer. You can see that it was correct. You look down at the solution, it will walk you through kind of what we did. We can take the log, simplify that, and solve for dy over dx. So the process, anytime it's going to ask you to use logarithmic differentiation, that's kind of the process. As you take ln of both sides, and once you do that, you can take the exponent and move it out front, because of the properties log base b of, well, let's just use ln. ln of a to the b power can be written as b times ln of a, and that's just a property of log that comes in handy when you have a to a power. And then once you do that, you take the derivative of both sides, and the key here is to remember the derivative of ln of y is 1 over y times dy dx. And then you take the derivative of the right-hand side, whatever that ends up being, and then the key is to solve for dy dx. So you have whatever is on your right-hand side times y, but you want to write y as a function of x. So doing that there. And I can drop my parentheses here because this is all being multiplied together. So I don't need that. But if it was like a plus b, I would definitely need parentheses because it's going to be distributed to each term. But in this case, we don't need them because it's being multiplied. So we can drop the parentheses. So hopefully this video helps. If you have any questions, please let me know.